Okay, hello everyone. This is Bilal Bashir, and as promised, this is a lecture for the revision of the first topic in A2. Now, the entire topic is divided into four parts. The entire revision plan is divided into four parts, and I'll brief you on that first. The second thing is the lecture would be in English. The reason it is in English is because you people have already learned this concept. You have taken classes for that, and it was in English and Urdu. Now, giving this revision session in English, which would enforce terminologies and the concepts and how to write your answers and understanding of the graph, that would improve your writing skills. Or else I could have simply given it in Urdu, which would have been more convenient for me as well. So people with poor English skills, I want you people to improve your game and accept this lecture as it is, rather than complaining and whining about it. Why did I not give it in Urdu? Now, coming back, there are four parts. Initially, the introduction. I will not be making any graphs for the introduction. I'll just be explaining them. The second concept, derivation of demand curve. The third concept, parallel shifts. And the last concept is pivotal shifts. So, what I would want you people to do is take out your registers, a rough copy, and simply start making points rather than just listening and watching to the videos, because I'm not dancing over here. I'm not cracking jokes. You will be getting bored, and eventually you'll stop watching the video. So, my advice is open up a register, write down key points, although you have written them in your Mavericks, that does not matter, but still write down those additional points even if they are repetitive. Take my advice seriously. I know you're going to get bored, and the only reason for boredom is I'm not Katrina Kaif, I'm not dancing, I'm not doing a romantic show. You people are going to get bored. All right. So if you're writing, that'll keep you engaged. I'll try to start and complete everything in an hour or so. That is what I've planned. All right. So let's get started. Now, what is utility? Utility is basically the satisfaction from consuming a good or a service. Whenever I or you consume anything, it is because you feel satisfied by consuming a particular good. I might have 100 rupees and I would consume a burger, whereas you have 100 rupees and you would consume fries. Now, why did you not consume the burgers? Because for you, spending 100 rupees on the fries gives you more satisfaction. Hence, consuming fries for you has a greater value for money because it gives you a greater satisfaction. The second concept is marginal utility. Marginal utility is basically the satisfaction consumed from one additional unit. What this means is when I consume the first unit, I get a satisfaction of 80. When I consume the second, only the second unit, so from the second unit, I get a satisfaction of 50. Now remember, it is going to decrease. Why? If I drink the first glass of water, I am satisfied because my thirst has been quenched. When I consume the second glass, it might give me a satisfaction, but obviously lower than the first unit. When I consume the third unit, it's going to further reduce my satisfaction. So the marginal utility means utility from one unit. Whichever unit you're talking about, the second unit, the third unit, the fourth unit, only one utility. Marginal means one. So from one unit, which one unit? The second unit, I got a satisfaction of, let's say, 50. For the third unit, I got a satisfaction of, let's say, 20. For the fourth unit, I got a satisfaction of 0. And for the fifth unit, I got a satisfaction of -10. So marginal utility is basically diminishing. As we consume more, the satisfaction tends to decrease. You can see it for yourself. If you're thirsty, go drink a glass of water and then drink another glass of water. And then talk to yourself and see whether you were more satisfied on the first glass or the second glass. Because the marginal utility is negative, it's diminishing, the graph looks something like this. I would label utility over here and the units over here. And this is my marginal utility. At this point, the marginal utility is equal to 0. So whenever the marginal utility is equal to 0, this means that this unit, let's say the fourth unit, is giving me a satisfaction of 0. And if I were to make a total utility graph, I could make it with this graph, or I could simply extend this graph below. The total utility would increase, and when the marginal utility is 0, after that the marginal utility is negative. Hence the total utility would start decreasing. So I can make it a graph below the marginal utility, or I can simply make it with the marginal utilities graph. So I can make it either way, whatever suits me. You might find this graph, the black ones in your book, but this is equally acceptable. All right. So the rule: marginal utility is total utility is maximized where your marginal utility is equal to 0, right? And marginal utility is known as diminishing marginal utility because every unit that you consume, the utility decreases, diminishes. Marginal utility has a negative relation with the units, means when your units are increasing, the marginal utility is decreasing. Hence, it is a downward sloping curve. The formula for marginal utility is change in total utility divided by change in units or the quantity, right? So that is the introduction for this chapter. Moving on to the next concept of derivation of demand curve using marginal utilities. All right. So the first method is marginal utility. Using marginal utility, we are going to construct a demand curve. Now, for this, you need to learn how to make a data, right? So we are going to assume some things. Let's say price of A. The price of A is equal to $2. Now we need to keep this value simple and an even number. You will know why even number in a bit. The next thing, utility per dollar spent somewhere else. Now this can be any number, all right? So let's say it's 5. And now I'm going to construct a table for A. Units, marginal utility of A, right? So 1 unit, 2 unit, 3, 4, 5. Let's say, okay. 40, 20, 10, 5, and 2. All right. So now I'll explain the data. The price of A is $2. You can buy a product A for $2. And if you have a lot of money, right? You can spend your money on A or you can spend it somewhere else. If you decide to spend it somewhere else, for every dollar that you spend, you get a satisfaction of 5, a marginal utility of 5, right? Now my question is pretty simple. Would you be consuming the first unit of A, or would you be spending it somewhere else? Now, in order to answer that question, we need to calculate marginal utility of A divided by price of A. So what basically this would give me is For every $1 I spend on A, how much satisfaction I get. So for example, if this was 40 because of this, and the price is 2, 40 divided by 2, this gives me 20. So this 20 basically means that when I spent $1 on A, I get a satisfaction of 20. Whereas if I spend $1 on something else, I get a satisfaction of 5. So as a rational consumer, my objective is to spend my money in such a manner that my utility maximizes. So I'm going to consume the first unit of A. Now, how am I going to state this in my answer? I'm going to say the marginal utility per dollar spent on A. All right, marginal utility per dollar spent on A. So for the first unit spent on A, every dollar gives me a marginal utility of 20. Moving on, 20 divided by 2. This gives me 10. So for every $1 I spend on the second unit of A, I get a satisfaction of 10. Moving on, 10 divided by 2 gives me 5. Now, for every $1 I spend on the third unit of A, I get a satisfaction of 5. And if I spend it somewhere else, I get a satisfaction of 5. So it does not make a difference, right? I'm going to still consume my third unit, but I am not going to consume my fourth unit because the marginal utility per dollar spent on A is 2.5, whereas I can get more satisfaction if I were to spend my money somewhere else. So when the price is 2, I'm going to write it over here. When the price is $2, my quantity demanded was 3. All right. Okay, so I need to write it. Price $2, quantity demanded 3 units. All right. Now, because I need to link it to the demand curve, I need to change the prices. So let's say the price of A is now $1. How would this entire data change? The entire data would remain the same, the units would remain the same, the marginal utility would remain the same. Because if I drink a glass of water for $2 and I get a satisfaction of, let's say, 40, and if I were to drink the same glass of water and the price was 1, I would still get the satisfaction of 40, provided both scenarios, both the scenarios, the glass of water that I'm consuming is the first one. So if it is for $2, I get a satisfaction of 40. If it is for $1, I still get a satisfaction of 40. But what changes? The answer for this changes. Marginal utility divided by the price of A. So instead of dividing by 2, now we are dividing by 1. Now most of you might have realized already that what is basically happening, because of the fall in the price, the marginal utility per dollar spent on A is increasing, which means it's more value for money. It's giving you a greater satisfaction than you could have earned it somewhere else, the satisfaction that you were getting somewhere else. All right. So 40, 20, 10, 5, and 2. Now, my question is, would I be consuming the first unit of A? The answer is yes, I would be. Reason is because I'm getting a greater satisfaction per dollar compared to if I were to spend it somewhere else. Would I spend it on the second unit? Yes, I would. On the third unit? Yes, I would. On the fourth unit? Yes, I would. On the fifth unit, no, I would not spend my money on A because it's giving me a satisfaction of 2 per dollar, whereas I could have achieved a greater satisfaction by spending it somewhere else. So when the price drops to $1, my quantity demanded increases to 4. Now using this, I can just construct my demand curve, and I would say a normal demand curve. When the price is 2, the quantity demanded is 3. And when the price falls, the quantity demanded increases. So using marginal utility, I was able to construct a demand curve. Now this demand curve is basically the demand curve of an individual. So when I am writing in my answer, I need to link it to the market demand curve by just stating the fact that the sum of all individual demand curves would make the market demand curve. As the individual demand curve is downward sloping, hence the market demand curve would also be downward sloping. Now, the key part over here is how to make the data. All right. So I'm going to make the scenario as it is, how it was initially. The price was 2, everything was the same. Now, how did I construct a data? I would recommend you to understand how to construct a data rather than memorizing the data, because in the paper, if you forget something, game over, right? So we need to know how to make the data. Now there is a technique. What I did was, this 2 was multiplied by this 5 and I got an answer 10, right? So what I did was, I thought in my mind, how many units do I need to consume? So before I started the question, I thought of 3 and therefore I wrote 10 over here, right? So what you can do is you can write simply 10 and erase everything. So you would be having something like this. Your consumption would automatically stop at 3. If I were to write 10 on the 4th unit, my consumption would stop at 4th unit. I thought of 3, therefore 10 came over here. Now, as we move up, I would simply double them. And as I would move down, I would half them. So 2.5, I did not write 2.5, I wrote 2. It's acceptable. Okay. Now, what happened is, my consumption initially was at 3 units. And when I decreased the price, now remember, when I told you to choose a price, I told you to choose a price that was even, 2. So that in the next scenario, when I decrease the price, instead of decreasing 2 to 1.5, I simply halved it. So 2 became 1. If you thought of 4, 4 would become 2. We need to decrease the price equally into a half, right? So what would happen when I do this? My initial consumption would stop at 3 when the price is 2. And when I decrease the price to 1, my consumption would be the 4th unit. So how did I make the data? Multiply, paste it on any unit that you wish to stop consumption at, double it, half it. Whatever the price is for the next data, you'll simply half it. So when you're answering such questions, you're going to make this data first and you're going to explain it. Why are we stopping at the 3rd unit and we're not consuming at the 4th unit? And then you're going to assume that, assuming that the price of A now is 1, we would consume the 4th unit. You would have a data something like this. And then you're going to construct a demand curve. As simple as that. All right. Now, moving on to the next part is constructing a demand curve using indifference curve and budget lines. Right. Now, demand curve can be constructed by 2 ways, indifference curve and budget line being the first way and marginal utility being the second way. All right. So, the question the examiner can ask in any manner, you should be prepared for both constructing a demand curve using marginal utility, which means you need to construct a data, and the other thing, budget line and indifference curve. So a budget line, what is a budget line? Budget line simply shows the combination of goods that can be consumed with a given budget or an income. Let's say we have good M and we have good N, and this is my budget line AA. So I can consume A units of M and let's say B units of N, right? And this is my indifference curve. So what does this indifference curve mean? Indifference curve basically shows the combination of two goods when consumed would provide the same satisfaction. So if I were consuming at this point on the IC, I would get a satisfaction of 120. If I'm consuming at point X, I would get 120. If I'm consuming at this point on the IC, I'd get 120. Say, now I'm consuming, let's say, 5 units of N. We don't need to label for M because for the demand curve, any change on x-axis can be portrayed on the curve below. So no change required for N, although things would be changing, but we need to be sure that we are labeling for the x-axis. But let's label it for y-axis as well. It does not matter, right? Now, point X is basically the equilibrium. Now, there are two equilibriums. The first equilibrium is where your indifference curve and the budget line are tangent. What happens at that point is your budget is fully exhausted and your total utility is maximized. Hence, there is no tendency to change. Whenever we talk about equilibrium, we need to state that there is no tendency to change, right? So this is your first equilibrium. Let's assume the price of M and N have decreased. If the prices have decreased, I can buy more of M, more of N. Hence, the budget line would shift outwards parallel. Okay, so let's say this becomes C and this becomes D, right? I can simply write B and B1, or I could write C and C1, does not matter. Now, because my purchasing power has increased as a result of the fall in price of M and N, I would simply increase my consumption and my indifference curve would move on to a higher point at IC1. So I am consuming more of M and more of N, let's say 6 of N and 6 of M. So when the prices are decreasing, I'm consuming more of M and more of N. I need to construct this. I need to derive a demand curve. What I would do is I would simply make a demand curve 5, 6. This is the quantity for N and this is the price. A simple demand curve. When the price was 5, when the quantity was 5, my price was, let's say, $3. And when the quantity was 6, my price was, let's say, $2. When the prices decreased, my consumption increased. Now, tell me at what point is the new consumer equilibrium? Initially, it was at X. Now it is at Y. So what did we prove over here? When the price of M and N decreased, the quantity demanded of N increased. So we have linked it to the demand curve. Again, the same concept. This is an individual demand curve. And if we need to construct a market demand curve, we'll simply add all individual demand curves. The demand curve for an individual is downward sloping as well as for the market, right? You need to write that in your answers. Now, we talked about the first type of equilibrium, which is where indifference curve is tangent to the budget line. We are maximizing the total utility. The other consumer equilibrium is known as the equi-marginal principle, where marginal utility of A divided by price of A is equal to marginal utility of B divided by price of B. A bit earlier, we talked about this concept. We used this in our data. And what this basically means, the utility, the marginal utility per dollar spent on A, if it is equal to the utility per dollar spent on B, is equal. Again, the marginal utility per dollar spent on A is equal to the marginal utility per dollar spent on B. If they're equal, this means that your total utility is maximized, right? So total utility is maximized if I'm getting the greatest satisfaction I would not change my consumption. Hence, there is no tendency to change. This is a graphical method to show the equilibrium, and this is a numerical way to show the consumer equilibrium. The issues with these theory is that the utility cannot be measured, and the second thing is rationality of a consumer. Consumers are rational. This theory assumes consumers are rational, which means that they make decisions based on what maximizes their total utility. However, practically and in reality, people do not make decisions on the basis of what maximizes their total utility. Rather than they would buy things that do not want just because they are advertised in such a way that we find it important to buy those products, but they have less satisfaction in our life. So we are spending our money in an irrational way. Another way a consumer is said to be irrational because he might be taking actions on the basis of emotions. All right, for example, a person passed away, his son wants to buy a car, and he finds the first car of his father which was discarded or which was sold. Let's say it was sold. Now the son finds the same car with another person and he wants to buy it. He'll buy the same car above the market value. Now, why is he giving more value? Because it has an emotional value. But does that maximize his total utility? The answer is no. And hence, this customer is acting irrationally because he is making decisions on the basis of emotions. Whenever you're making decisions on the basis of emotions, you're not maximizing your total utility, rather than you're just acting irrationally. Another way a person would act irrationally is if he is addicted to a product. So let's say if a person is smoking, what happens is he's smoking and he's continuously smoking, and his utility does not diminish, and that is why he keeps on smoking. Let's say he smokes 20 cigarettes a day, 30 cigarettes a day. Had the marginal utility been decreasing, he would not have been smoking. And let's assume that the marginal utility is decreasing and has become negative. He's still consuming it. So what does that show? A customer is consuming a good which is dissatisfaction, which gives him dissatisfaction, and he's still consuming that good. So he's not rational, he's irrational. So whenever a question might come up and asks about rationality, you can say that this theory assumes that the consumers are rational, but in practical life, they are not rational because emotions, advertisement, addiction. Okay, so this theory becomes irrelevant. Practically not irrelevant, but because this is associated with behavioral economics, so it's a good insight to how marketing and advertisements are also done. So triggering those nerves and those values in an emotional way in an advertisement would make you purchase a product that you don't need, right? So that is what we see in advertisement that are persuasive. They tell us to consume a product, they make it interesting so that we start consuming that product. However, we don't want that product, we still start consuming that product, right? So let's move on to the next part, and which is more graphical and parallel shifts. Now, a budget line would shift parallel if there are two things. Number one, price of both goods change, and number two, if the income slash budget was to change. All right, so we're going to look at the graphs for both. Now, I'm going to make the graph, and then you need to make the graph opposite to it. That would be a good way to practice it. Let's say I'm making a graph for price of M and N decrease, let's say increasing. We did decreasing in the last concept, so let's increase the prices, right? So what is happening? N, M. Initially, my budget line is, let's say, AA, and my equilibrium established at point X, where IC is tangent to the budget line AA. I'm consuming 10 units of M. I'm consuming 5 units of N. No issues? Now the prices have increased. When the prices have increased, my purchasing power decreases. So if I had a budget of 10, initially I could buy 5 units of N and 10 units of M. But now the prices are high. I'm not able to buy 5 units of N and 10 units of M. My purchasing power has decreased. So what would happen? My budget line would simply shift inwards. A parallel shift to BB. Now, because of this, I would be consuming less N and less M, let's say at point Y. So this becomes IC1. I'm consuming 5 units of M and let's say 3 units of N. So when the prices increased, the quantity demanded for M decreased, the quantity demanded for N also decreased. So this is what we would expect to see normally. Hence, these both goods are normal goods because they're following the law of demand. Now, let's look at another case. I'm going to make the same diagram. A, and this is my initial equilibrium point X. IC, dotted line 10, dotted line 5. Okay. Okay. Let's make it shift inwards to BB. Now, where my new equilibrium established, it is up to me. I can make my new equilibrium over here, or I can make it simply below here, or I can make it in between, shifting it diagonally inside. It's up to me. So we did a diagonal shift inside on the indifference curve to show that both the goods are normal goods, but we can, simply change where my new equilibrium would be. Let's say my new equilibrium comes over here. So what is going to happen? IC1. I'm consuming 12 units of M and I'm consuming 1 units of N. So the price increased and the quantity demanded of N decreased. Well, this looks pretty normal. When the prices increase, the demand would decrease. Hence, this is my normal good. And on the other side, the price increased and the quantity demanded of M increased. Whoa. Now, this does not look like the law of demand has been followed. Hence, this is known as a Giffen good. So, a good that does not follow the law of demand is known as what? A Giffen good. Okay. Now, if I made my point Y over here, N would have been a Giffen good and M would have been a normal good. So you can make a Giffen good, you can just make one Giffen good and the other would automatically be a normal good. But in this graph, we can make two goods that are both normal. We cannot make a graph in which both the goods are Giffen goods. Does this make sense? Right? So what you would be doing now, you need to pause your video. You need to make a diagram for when the price of M and N decreases. You need to make a graph to show normal goods, both M and N, and then make one graph, show one good as a normal and the other good as a Giffen good. Okay. So, hopefully, did you practice? Now, let's say my income is increasing. How would I make a graph for that? If my income is increasing and I'm consuming N and M units, initially this is A, and my equilibrium established at point X, let's say IC, dotted line 5, 4. My income is increasing. I'll be able to purchase more of M and N. Budget line would shift outwards to BB. Now, if I shift my IC diagonally upwards, I would be consuming more of M and let's say more of N. Income increased, the demand for M increased. The demand for N increased. Obviously, when the income increases, the demand would increase. This seems to be a normal behavior. Hence, these goods are known as normal goods. However, if there was a twist, let's say the income is increasing, and I would make the same graph, let's say AA, and my indifference curve is at point X. I see dotted line 5, dotted line 4, and let's say I shift my budget line outwards to BB. Now, the final equilibrium, the point Y and IC, is up to me to establish. I can establish it on the top corner, I can establish it on the bottom corner, it all depends on me. So let's try to make it on the top corner. So if I make it on the top corner, let's say at this point, I am consuming 8 units of N and let's say 4 units of M. My demand for N increased and my demand for M decreased. So the income increased, the demand for N increased. Now this is a normal behavior. When the income increases, the demand would obviously increase. But the demand of M decreased. This is an abnormal behavior, and in economics we call this as inferior goods. Right? Now, what is the difference between inferior and Giffen? Inferior goods arise when there is a change in income, and Giffen good arise when there is a change in price and the demand. The law of demand is not being followed. A Giffen good would show a positive relation between price and quantity demanded, and an inferior good would show a negative relation between income and inferior goods. You know why I'm saying positive and negative relation? Because if you're smart enough and you need to construct a demand curve for a given good, it would be an upward sloping curve. And when you need to construct a curve for inferior good, you would label income on this axis and the quantity on this axis, and you would show a downward sloping curve for an inferior good. You know what? You can do it on your own and then you can just send me on WhatsApp and I'll have it checked. The second thing that you need to do is, I made the graph for income increasing. You need to make a graph for income decreasing. So what would happen? You would make the first graph. You need to show both of them being normal goods, and then you need to make another graph where you show one graph to be normal and the other to be inferior. The point to be noted is that in a graph you can show two normal goods, but you cannot show two inferior goods. You can just show one inferior good and the other would automatically be a normal good, right? So you can pause the video and do it yourself, and then when you're done, we can move on to the last bit, which is pivotal shift. At this point of time, most of you might be exhausted, and my advice to you is you can stop the video, you can do something else, get yourself fresh, and then come back for this pivotal shift. But do not just watch the video. You are just wasting your valuable time. If you're just watching the video, you're just wasting your time. If you're making notes, you're trying to understand, you're doing as I say, and you're writing important statements, only then it is effective. Or else you could have just watched a season. It does not matter, right? So let's start off with pivotal shift. A pivotal shift would occur when a pivotal shift would occur when the price of one good changes. Okay, so this is going to be a bit more interesting. So let's assume M price decreases. Okay. The first step is to label your goods. We're going to obviously pivot on x-axis. That is what we have practiced, and that is what we're going to continue. N and M. Okay. So if the price of M is decreasing, I would be able to buy more of M, and N would remain the same. So a pivotal shift would something look like this. So it shifted from AA to AB. Now, the most critical part of this graph is to make an imaginary line. The imaginary line is going to be parallel to the new curve AB, would intersect the old curve AA. Remember that. So parallel to AB intersecting AA. The graph would have an imaginary line, something like this marker. So I'll make this. Okay. It's not perfectly parallel. It should do the trick. At this point, we plot X where there is an intersection. Let's say we are consuming, well, let's keep it on single digits, 5 units of M. Now, I need to plot Y on the imaginary line. Imaginary line, plotting Y, always remember, but use your common sense. Prices have decreased. The quantity demanded should increase. So Y should not be over here. It should be over here. Let's make this point Y. Dotted line 7. So this is my substitution effect. And then I would simply join X and Y to make IC, right? Sir, why did you remove this IC when it was intersecting your budget line AB? I needed to make another point over here. That is why. Simply, you can just intersect it. It does not matter, right? So once you're done with this, you're going to make point Z. Point Z will always be on the curve AB. Now, prices has decreased. We need to increase the consumption, right? So when we increase the consumption, it has to be on the right of the 7. Means where we have plotted our Y, we have to make Z on the right of Y. So let's make it over here. That is why IC1. Dotted line, let's say this is 9 units. Now this is my income effect. Always remember, X to Y, substitution effect. Y to Z, income effect. Point on the imaginary line, substitution effect. To the new indifference curve, income effect. So if you're following my guidelines, so a simple rule, X to Y would be my income effect. And from the imaginary lines point Y to Z would be my income effect, right? So initially the equilibrium is at X and the final equilibrium is at 9. So this is something that you need to realize. Now, what is 7? 7 is simply a middle line that distinguishes between substitution and income effect. Simply, that is it, right? Okay, so what is the substitution effect? A substitution effect basically tells us when product M is cheap, we would substitute expensive N, the comparatively expensive N, for the cheaper M, in such a manner that our total utility remains the same because we are on the same indifference curve. So substitution effect is what? when we substitute the comparatively expensive for the cheaper product in such a way that the total utility remains the same. Now, at point Y, we have some income remaining. When we have income remaining, we can buy more of M. Hence, our total utility also increases. So the income is remaining, we can buy more of M, and the total utility is increasing. That is why we move from Y to a higher indifference curve, and this is known as my income effect, right? So this is the overall concept. Now, had I made, now you can just ignore the black lines, I'll just erase them. Beautifully removed. Okay. Now, if I made my point Z right on the corner over there, let's say this is point Z. This becomes my IC1 and this becomes my IC. So now we are consuming 5 units initially, we move to 7, and then from 7 all the way to 2 is my income effect. Now this is a Giffen good. Why is this a Giffen good? Because initially we were consuming 5 units, but now we are consuming 2. The prices have decreased and the quantity demanded has also decreased, making it a Giffen good. All right. And another way of stating it is income and substitution effects are in the opposite direction. Whereas income effect is more powerful, hence it is a Giffen good. And there is another point Z I could have produced or made in between X and Y. This can be another indifference curve. So what you need to do is on a graph, you need to make the same thing. Do not make this IC1, but instead make the black IC1 and make a dotted line. Obviously, it would come to 6. So 5 to 7 is my substitution effect, and then 7 to 6 would be my income effect. Again, income and substitution in the opposite direction, but in this case, substitution effect is more powerful. Hence, this is an inferior good. Right? So you need to be able to make all these 3 graphs, normal, inferior, and Giffen goods, and you need to be an expert in that. We did for price decrease, you can practice for price increase, and then you can send me your 3 graphs for me to check them. The final thing before we end this concept, people get confused. They're not confused. X to Y is the substitution effect. Every student would perfectly show me that. Where they're confused is, where would the income effect start from? So for example, in this situation, they would make the income effect from 5 to 2. Now this is incorrect. So 5 to 7 or X to Y is your substitution effect, and then Y to Z. No matter where Z is, what direction, you don't need to focus on that. You need to make it from Y to Z. That is your income effect, and this is the point where most students blunder out, right? So Y to Z, there'll be a full arrow, and in this case, to be right, it should be from 7 to 2, all right? So ending the class now, do give me a feedback. Allah Hafiz.